Alright, in this video we're going to show you how the Pythagorean theorem is derived, where we get the theorem from, and then put it into practice in just a basic, here's two side lengths, what is the third one? Okay, these are your more basic problems. So the first things first, I'm going to make a triangle on this grid paper so I can show you how I find the Pythagorean theorem. So I'm going to make this particular triangle a 3 by 2 triangle. So down 3, the side length is 3 over 2, and then I'll just connect these. Alright, so now I have a right triangle that's 3 by 2. Alright, I want to show you now how I get the Pythagorean theorem. So the first thing we're doing is we're going to assign values to each of these. So this is A, B, and C. The hypotenuse is always C. Again, this is the hypotenuse because it is adjacent to the right angle. It's the longest side on the right triangle. So A is the side length of that triangle. That's 3. A squared, given what we know about area and area of a square, would be the area of a square made off of that leg. So if I made a square off of the leg of this right triangle, the area of this leg, of this square, would be 9. Because if the length of our right triangle's leg there, A, is 3, then every side of the square made from that leg has to be 3 because a square has equal sides. And then if we found the area of that square, we have to do 3 times 3, side times side, or length times width, and we would get 9 as the area of this square. Also, if you counted the amount of boxes on the inside of here, they're all 1 square unit, there would be 9 boxes on the inside of this square. Once again, geometrically proving that the area of that square actually is 9. Again, if we do the same thing down here, this side length is 2, so we should already know that the area is going to be 4, because all of our side lengths have to be 2, and 2 times 2 is 4. But I'll draw it just to prove it to you. Alright, so the inside there is 4. Now here comes the tricky part. In our formula that we already know, or should already know, it's a squared plus b squared equals c squared. So that means a squared is the area of the square made from the side length plus the area of the square made from the other side length equals the area of the square made from the hypotenuse. So right now we found the area of the square of one of the legs and of the other leg. Now we still have to figure out what the area of the square of the hypotenuse is. So pretty easily, this is how we're going to figure that out. To get a perpendicular line off our C line right here, because we want to draw a square, which means it has a 90-degree angle and be perfectly perpendicular, we need to figure out what the slope of this line is. So we know that this line right here is down 3 and over 2. So that means our slope is negative 3 over 2. To get a perpendicular slope, we need to take the opposite reciprocal. So we need to change the sign and flip our fraction. So we're going to go from negative to positive, and from 3 over 2 to 2 over 3. So that means that starting at this point right here, I'm going to go up 2 spaces, over 3 spaces, connect my line, up 2 spaces, over 3 spaces, connect my line. Okay, now I have a square off that leg. We know that if you add 9 and 4 together, we're going to get 13. So we know that the area of that square is 13, but I'm going to prove to you that that's actually what happens. So I'm going to break this square up into things that I know. So here's a square right here. Okay, so that's with 1 area unit. Now I can create 4 triangles off of here. Alright, now I have 4 separate triangles that are all the same in space. So now I'm going to turn one of those triangles into a square, which if you watch the area and perimeter video, you would see that if by turning my right triangle into a square, I can figure out the area of that square, cut it in half, and get the area of the triangle. So I'm going to turn this triangle into a rectangle. The rectangle's area would be 2 times 3, so length times width, let's say, was 6. And so now that means that the inside of that triangle is worth 3, because it is always, the area of a triangle is always half that of the rectangle it could be made into. So these are all going to be worth 3 now. So again, 3 times 4 is 12. We have 4 triangles, all with an area of 3, plus 1 is 13. So the interior of the area of this square out here off the hypotenuse is worth 13. Okay, so now we know, now we can see geometrically how this algebraic equation works itself out. Okay, the last step though is we're not trying to find the area of the square off the hypotenuse. That's not the answer we're looking for. We're looking for the length of that line. Well, to find that, we're going to have to take the square root of the area. Okay? The area of a square is always its side times its side, which, because it's a square, means that both side lengths have to be the exact same. So in order to figure out what one side length is, we can take the square root of its area and know that whatever two numbers are multiplied together to get that area have to be the same number. Okay, so if I take the square root of 13 and the square root of c squared, I'm going to get the square root of 13 will be our side length equals c. Okay, now we could estimate our side length and say that it's roughly probably a little closer to 3.5. But because this is 2013, we have a calculator and we can find exactly what our answer is. So the square root of 13 would be 3.6, roughly. And that would be our answer. That side length is 3.6. Notice that it is larger than the two other side lengths of 3 and 2. Again, notice that it is not, our answer is not 13. Okay, we don't want to know what c squared is, we want to know what c is. So this is geometric proof right here, combined with our algebraic proof that the side length, the hypotenuse of a triangle that has side lengths of 3 and 2 is the square root of 13. Okay? So I hope this helps you figure out where we get the Pythagorean theorem from and how to prove that. Now I'm going to quickly show you how to put that Pythagorean theorem into practice. Okay, so for starters, let's just use, let's make our right actually. So I'm going to make a right triangle here. Okay, and what we're going to do is we're going to label this with, let's say this side length is 8 and this side length is 5. Okay, and this one is unknown. So first and foremost, we need to label the triangle with our parts of our Pythagorean theorem. So 8 is going to be my A because it is a leg. It is one of the sides that forms the right triangle, the right angle right here. And I'm going to make 5B. The legs are always the two sides that create the right triangle. So the right angle. They're going to create an L when they touch each other. They're always going to be the shorter two legs, the shorter two sides of the triangle. So that means that this long leg right here, this long side here, is our hypotenuse. Okay, and that's what we need to find. That's what we're looking for. So the Pythagorean theorem is going to help us figure out how long is this other side length, the one we don't know. So we have to put this into our theorem. So we know that it's a squared plus b squared equals c squared. Next thing we need to do is we need to plug in our values to replace our variables. So a was 8, so 8 squared plus 5 squared equals c squared. 8 squared is 64, 5 squared is 25. And so if we add those two together, we're going to get 89 equals c squared. And again, we just watched our video about how we derive the Pythagorean theorem. 89 is the area of the square created from the hypotenuse. That is not our answer. That's just its area. So to find the actual length of the side, we must take the square root. And so the square root of 89 is going to be a little bigger than 9. It is exactly actually not exactly, roughly 9.4. Okay, notice again, 9.4 is greater than 8 and 5, which means that it fits the characteristics of a right triangle. And so here's all of our work. This is the easier application of the Pythagorean theorem. You're given both legs, you're asked to find the hypotenuse. All we need to do is add them together and take the square root. The harder version of this, and it's not necessarily incredibly difficult, but it is harder. There's an extra step you need to remember, is if we are given the hypotenuse and a leg and asked to find the other leg. So let's say that this leg is 11 and this leg is 17. This side length is 17, the other one's 11. Well, now we need to find our right angle, so it's right here. And now we need to label them with our variables. So 11 is going to be my A. It is one of my legs. I know it is a leg because it's one of the side lengths that creates the right triangle, the right angle. Alright, and my unknown side length is going to be B because it's the other leg. It's when A and B hit each other or touch each other, they create a 90-degree angle. I know that it's also B because it's shorter than this leg out here. I can eyeball that and tell that it's shorter. So that means 17 must be my hypotenuse, so it is C. Okay? It is across from or adjacent to the 90-degree angle, and it is clearly the longest leg, the longest side length. So let's plug this back into our equation and solve for B. Okay, so we'll have 11 squared plus B squared equals 17 squared. Notice, I did not put 17 where B was. We don't know B, so it has to be left by itself because that's what we are solving for. Okay, so 11 squared is 121. And 17 squared is 289. Alright, here comes the tricky part. I want B squared by itself so that I can take the square root of it and get my answer. This is just like solving a two-step equation. I need B squared by itself. I have 121 on one side and 289 on the other. If I want B squared alone, I need to get rid of that 121. Well, if I'm going to take it away from this side, I need to take it away from the other. So I'm going to subtract. So now I have B squared equals 168. Let's check my math in the calculator. Mental math is great, but let's always make sure we check our math in the calculator. I'm correct, per usual. So now, again, all we need to do is find the square root of B squared and 168, and we will have our answer. So the square root of 168 is 12.96. And if we were taking a test, multiple choice test, most likely this answer would be rounded up to 13. Okay. For the sake of our tests, if you wrote 12.96, I would not take off. If it were multiple choice, you just need to be aware of the fact that the answer choice that they will probably put on the test is 13. Okay, so again, these are our two basic applications of the Pythagorean theorem. On one, we were given the legs, asked to find the hypotenuse, which is very simple because all we have to do is plug the numbers in, square them, add them together, and take the square root. And the other application, we're given a leg and the hypotenuse. We have to plug those in, make sure to put them in the right spots, square them. Then we need to subtract the smaller area from the larger area, because if 121 plus whatever the area is of B are added together to equal 289, if we subtract the area of the square made from A, we're going to get the area of the square made from B. Then we take the square root and we have our answer. So these are our two basic applications. Again, there'll be more videos about word problems, a couple of the more complicated applications of Pythagorean theorem, but this is the most basic applications.